Sulphuric acid. It is a very important chemical used in the chemistry laboratory. It is used in almost all manufacturing processes in industries. Sulphuric acid is manufactured mostly by the contact process and sometimes by the lead chamber process. Physical properties. Concentrated sulphuric acid is a colorless, oily and viscous liquid with a high boiling point of 388 degrees centigrade and high density of 1.84 grams per cm3. It is very corrosive and causes severe skin burns when in contact with the skin. Concentrated sulphuric acid has great affinity for water. That is, it is hygroscopic and dissolves in water, evolving large quantity of heat. When diluting sulphuric acid, add the acid to water slowly and stirring all the time to prevent the formation of separate layers of water and acid. Never add water to acid. If this is done for concentrated sulphuric acid, the great amount of heat evolved will form packets of steam, which will cause the acid to scatter and splash out. Chemical properties. Dilute sulphuric acid is a strong dibasic acid with its typical reaction with metals, alkalis, and carbonates. It reacts with metals to produce hydrogen gas, with alkalis or bases to produce salt and water only, and with carbonates to produce salt, water, and carbon dioxide. As a dehydrating agent, due to its high affinity for water, concentrated sulphuric acid is capable of removing water molecules from compounds like sugar and other carbohydrates, leaving behind carbon, ethanol, changing it to ethane, methanoic acid, converting it to carbon monoxide gas, oxalic acid to carbon dioxide and carbon monoxide. Copper sulfate pendihydrate, transforming it into anhydrous copper sulfate. As a drying agent, concentrated sulphuric acid is a drying agent used to dry many gases, example hydrogen gas, chlorine gas, sulfur dioxide, etc., due to its hygroscopic property. It should be noted that the process of drying is quite different from dehydration, because drying removes water molecules without affecting the chemical composition of the compound, while dehydration will affect the chemical composition of the compound. As an oxidizing agent, concentrated sulphuric acid acts as an oxidizing agent in many reactions with both metals and non-metals. Example, sulphuric acid oxidizes copper to give copper sulfate, water, and sulfur dioxide. Sulphuric acid oxidizes hydrogen sulfide to give sulfur dioxide, water, and sulfur. Sulphuric acid oxidizes carbon to yield carbon dioxide, water, and sulfur dioxide. As a strong non-volatile acid, concentrated sulphuric acid can displace the more volatile acids, that is, the low boiling point acids, from other salts. Example, sulphuric acid reacting with sodium chloride gives hydrochloric acid and sodium hydrogen sulfate. Sulphuric acid reacts with potassium nitrate to give nitric acid and potassium hydrogen sulfate. Uses of sulphuric acid. A. Laboratory uses, that is, small-scale uses. As a drying agent for gases like hydrogen, chlorine, sulfur dioxide, etc. To acidify oxidizing agents like potassium permanganate and potassium dichromate. To produce hydrochloric acid and nitric acid. To produce ethane, carbon dioxide and hydrogen. B. Industrial uses: to manufacture fertilizers such as ammonium sulfate, calcium hydrogen phosphate, etc. To manufacture explosives, dyes, and drugs. To pickle or clean metals before electroplating. To make cellulose films and natural and man-made fabrics and plastics. As electrolyte in car batteries. To manufacture paints and detergents. In petroleum refining to remove waxes, gums, and many dark-colored compounds.